This is section 611, and we're in the new chapter, series and sequences. So we're going to practice writing out the first terms of a sequence. Now, we've examined multiple functions. We looked at polynomials, linear, quadratic, cubic, logarithmic, absolute value, and then small amounts of rational functions. They all had these special domains. If you remember, with a rational function, you couldn't divide by 0, and with logarithmic, you can't have a negative or 0 inside the log. Now, why does this happen, or important? It's because with this new function, a sequence, it's a special type of function where we say that our domain are natural numbers. Now, what does that mean? That means our domain, our values for n, are going to be greater than or equal to 0, but they can't be fractions. So whenever we're talking about the context of any type of sequence, we have to make sure that we're not plugging in any fractions. They're always these nice whole numbers, 1, 2, 3, 4, 5, 6. Now, if we look at this example, 1/2, negative 3/4, 9/8, and negative 27/16, each of these numbers are called a term. So we would say that this is my first term, this is my second term, this is my third term, this is my fourth term. So if I said, what's my fourth term, you would say negative 27/16. And it's going to make it easier for us to identify those values. Now, the traditional way for us to be able to write this is going to label it the function a. So our definition, a sequence is a function a whose domain is the natural numbers, right? So 1, 2, 3, 4, 5, 6. The value of my function a sub n is often written as a sub n and is called the nth term of the sequence. So the sequence could be infinite, so the nth term is the infinite term of the sequence. The sequence itself is usually denoted using notation, and then my function with a comma, and then we state where we're starting. Now, traditionally, it starts at 1, but we can tell it to start at other places, if that makes any sense. Or we can write it like this. Here's our function, and then here is our start, and then here is our finish, right? And because it says infinity, we know that we would plug in values forever. So interpreting that, we would say a sub 1 is 1/2. My first term, a sub 1, is 1/2. My second term, a sub 2, is negative 3/4. My third term is 9/8. My fourth term is negative 27/16. Now you might be like, wait a minute, why are we writing like that? Well, let's look at our function, right? It's a sub n, and n is your term. So a sub 1, my first term. A sub 2, my second term. So let's look at a few examples. Write the first 4 terms of the following sequence. So here's our function. It's telling you to start with 1. So we just plug in 1. So 5 to the 1 minus 1 over 3 to the 1. Well, 5 minus, that's 0. Anything to the 0 power is 1. So now plug in 2, my second term. So 5 to the 2 minus 1. That's 5 to the first over 3 squared. Now you could simplify it, right? If you want, you could say 5 over 9. You can do that. That's no problem. My third term. So we can say 5 to the 3 minus 1 over 3 to the third. So that would be 25/27. And then my fourth term, that's going to be 5 to the 4 minus 1 over 3 to the fourth. So that's 5 to the third over, what was that, 81. But I could say 125/81. So I could write it out as a sub 1 equals 1/3. A sub 2 equals 5/9, my second term. A sub 3 equals 25/27. And then a sub 4 equals 125/81. Next example. Now, with this one, this is something that we saw in integrated 1. and we're kind of rehashing it out. It looks complicated, but it's called a recursive sequence. Now, a recursive sequence just means you're going to use the previous value. And it's always going to give you the previous value. Now, this is what I mean, right? So this is my actual function. And then, right, where we're starting. But it gives me already a term. It says my 0th term is 1. Well, why am I going to need that? Okay, well, let's plug in 1. So if I plug in 1, right, so my first term is 1 times f of 1 minus 1. Well, this is 0. Oh, I have to use my previous term. F of 0 is 1. So that's going to be 1 times 1. Now my second term. So f of 1 equals 1. So my second term. So now that's going to equal 2 times f of 2 minus 2. So 2 times f of 1. Well, what's f of 1? It's my previous term. So that's going to be, that's going to equal 2. F of 3. So my third term is going to be 3 times f of 3 minus 1. So that's going to be 3 times f of 2. Well, what was f of 2? Well, that was our previous term. It's right here. So that's going to be 3 times 2, which is 6. What's my fourth term? My fourth term is going to be 4 times f of 4 minus 1. So 4 times f of 3. What's f of 3? My previous term, so 4 times 6, which is 24. So I found my 4 terms. Let's do some quick practice. Go ahead and pause it. Try this one out. So that's the answer. So what did we learn today? We talked about series and sequences. We emphasized this idea of a sequence and how to write it out. So what are the basic elements of a sequence? So we have our function, and then we have our domain, meaning where our number is starting. Now traditionally it's 1, but we can tell it otherwise if we want to. And the idea is if you plug in those values, that's going to be your first term, all the way up to your nth term. Right? If I wanted to plug in 2, that would be my second term, etc., etc. This does conclude our lesson. If you have any other questions, please leave them in the comments.